everyone, thank you for being here. Today I'm going to try and help you understand a physics concept that I really struggled with when I first started learning physics and even math. It goes way back. Let's get into it. We're going to talk about physics and how integrals play into physics and what they have to do with each other. I'm going to show you an example that'll help illustrate how physics helps you understand integrals. Let's say you have a toy car and you have the ability to make it drive at a constant speed. Let's say 4 meters per second. I've just drawn what the velocity time graph would look like if your x-axis is time in seconds, y-axis is velocity in meters per second. So let's say your toy car is going at a constant speed of 4 meters per second for 3 seconds. I'm just gonna write those in. So let's say your toy car is going at a constant velocity of 4 meters per second for 3 seconds. Let's write something out. So if you do the dimensions here, you can see that seconds cancel out. This allows you to visualize the fact that if you calculated the area underneath this line for every second that goes by, you would be left with meters, which is a unit of distance. So this helps illustrate that the area underneath our curve, it's a line, is the actual distance traveled. This graph can help you visualize the concept of an integral and what it has to do with physics. All right, let's look at another example. If you had constant acceleration, your graph would look something like this. Since you know that acceleration is meters per second squared, you can write it like this. Meters per second per second. That's the unit for acceleration. Now, because this is the acceleration time graph, let's add in that time aspect of seconds. Now, something interesting is going to come up once we do this. See how these units cancel? You have seconds on the top here, and you have seconds on the top here, so those can cancel out. This leaves you with meters per second. Meters per second is the unit for velocity, and that should show you that acceleration is the derivative of velocity with respect to time. So this example should show you that calculating the area underneath an acceleration graph gives you your change in velocity. Because velocity's derivative is acceleration, the integral of acceleration should be velocity. And you can see that illustrated when these units cancel out and you're left with the unit for velocity. Now the thing is, in physics, you can do this for any kind of curve. If you have an acceleration graph, you can find its velocity using the integral. Let me show you something interesting. All right, I just redrew our graph just so you could visualize this a little bit easier. Because of our last example, you should still have the confidence to find the area underneath this curve and calculate the velocity of this acceleration time graph. Okay, from what you can see here, I've drawn some boxes underneath this curve. This is going to tell you the area underneath this curve. So if you would calculate the area of this box plus this box plus this box and add all of them together, you would get a pretty rough estimate of what the area underneath this curve would look like, which would be your velocity. But what an integral allows you to do is to calculate the infinitely small boxes that can be drawn underneath this curve. Oh, this is a vibrant yellow. Okay. So let's say you went in and you drew smaller and smaller boxes. As these boxes get smaller and smaller, your answer gets more and more accurate. That's what an integral allows you to do. Okay, from what you can see here, now that there's a ton of little boxes in here, you can still calculate every single one of the areas of these boxes, and it'll get you pretty darn close to what the area under this curve would be, which is your velocity. What an integral allows you to do is to take these boxes and make them infinitely and infinitely closer to each other. So on our acceleration time graph, this would give you the most accurate expression of what your velocity would be in this instance. So now that you have seen how acceleration and velocity time graphs are connected to each other, this can allow you to visualize what they have to do with each other by canceling out our units and by showing how taking smaller and smaller intervals allows you to go from one thing to another. Alright, I hope this video helped you. Thank you for being here and have an awesome rest of your day.